So describe fully a single transformation that maps the graph of y equals 1 over x onto the graph of y equals 3x. Okay, so I'm being asked to go from y equals 1 over x to y equals 3 over x. So we're looking at transformations of functions. Well, to go from one to the other, I'm timesing by 3. Okay, so what I want is, if I'm going to call f of x 1 over x, I'm timesing that by 3, so I want 3 f of x. If I've got 3 f of x, that means I must have done a stretch in the y-axis, so I've got a stretch times by 3 parallel to the y-axis. Okay, nice simple function transformations to begin with. B, sketch the graph of y equals 3 over x and write down the equation so many asymptotes. So again, what we're going to look at is we need to first of all think about what 1 over x looks like. So if I've got y equals 1 over x, okay, we should know what our basic reciprocal graph looks like. Okay, and we've got asymptotes at y equals 0 and x equals 0. Then if I go to 3 over x, all I've done is stretch times 3 in the y-axis. So all that's happened is I'm going to have stretched in that direction. My asymptotes, because they are already on the axis, do not change. Okay, I don't have any intersection points, so actually, for sketches of graphs, they are very, very similar. All that's going to happen is we got a little bit more of a gap, but you don't actually need to worry about that too much. Make sure you put in your asymptotes at y equals 0 and x equals 0. But these graphs for sketches are going to be very, very similar. Finally, part C, we've got find the values of the constant c for which the straight line y equals c minus 3x is a tangent to the curve. Right, what we need to think about, okay, is what this line has given us. Well, if we know that's a tangent, from our equation of a line in y equals mx plus c, I know straight away what the gradient is. So the gradient of my tangent has to be minus 3. Okay, so gradients, tangents, differentials. Okay, so I need to differentiate y equals 3 to the 3 over x. Sorry. Okay, which first of all means I need to get this in the form without any fractions so that I can differentiate it. So I'm going to rewrite this as 3x to the minus 1, which then means I need to differentiate. So f dash of x times by the power, take 1 off the power, will give you minus 3x to the minus 2. Now I know that minus 3x to the minus 2, because that is my gradient function, my differential, that's got to be equal to minus 3. And I've got a little equation to solve. I'm going to divide by minus 3 first of all. So I know that x to the minus 2 is going to be equal to 1. Therefore, I know that x squared is going to equal to 1. So x is going to be equal to plus or minus 1. Okay. That then means if x is plus 1, so when x equals 1, y is going to equal 3. When x equals minus 1, y is going to be equal to minus 3. So I've got my 2 points. Okay. However, I'm asked to find the value of c. All I've got to do is sub those points back into my equation here and I can find c. So if I use the first one, I know that 3 is going to equal to c minus 3 lots of 1. So all I've done is sub my x and y values into my straight line up here. So therefore c is going to equal 6. And on this one, I've got minus 3 is equal to c minus 3 times minus 1. Minus 3 times minus 1 is plus 6. Over the other side we take it away. So we'll have c equals minus 6. So we should end up with c equaling 6 and c equaling minus 6. Okay, function transformations to begin with, bit of sketching reciprocal graphs, and then a little bit of tangents to that function.